Okay, so today we're working on chapter 4.6. Okay, and chapter 4.6 is about, we're going to construct functions. Okay, construct functions. So, constructing functions, what we're going to do is you're going to have basically word problems, and we are going to figure out what the things in the tables or in the graphs mean. Okay, so what we're going to work on today, so the first one, for example number 1, if I tell you a pottery studio charges per hour. Okay, a pottery studio charges per hour plus a fee to bake your pottery. Okay, I don't know if any of you guys have ever taken like ceramics or anything, but when you make something in ceramics, then they have to do what's called fire it. Okay, or bake it. They put it in like a crazy hot oven. It's called a kiln. Okay.
I saw that. Our teacher did that.
Awesome. So they charge a fee to make your item. Okay, so you come, you make your item, but they also charge a fee to bake your pottery. Okay, so they're not putting it in like a regular oven. It's called a kiln. It's special. Okay. Here we're gonna say this graph shows, and I'm gonna put up a graph for you. This graph shows the cost of using the studio. The cost of using the studio for different amounts of time. We want you to find and interpret the rate of change and initial value. Okay, so we're going to find and interpret the rate of change and the initial value. Okay, guys, we should be writing here. Hey, Drew, we're taking notes, dude. Let's start writing on what you're doing. Let's go. Come on. Yes. Right now we're taking notes. Okay, guys, today. So, would it make sense that we're only going to use one corner of our graph? Okay, why would we not use a whole graph like this? Because it's impossible to have negatives. Okay, you can't have negative time that you spent there, and you can't pay negative money. Okay, so we're just going to use, this is called a quadrant 1 graph. Okay, and it's basically where all the numbers are positive. Okay, so on the bottom we're going to write the number of hours. Okay, and on the left side we're going to write the total cost. It's going to be in dollars. Okay, so over here is 0, okay, and these are going to go, we're going to go all the way up through 9. Okay, so actually I'm going to count by 2s. Sorry, so 0, so 2, 4, 6, and 8. Okay, and on the side we're going to count by 20s. So 20, 40, 60. We're going to try to take this all the way up to 160. Hopefully I wrote enough room. apologize that I didn't have these printed out for you guys. So our first point is over 2 up 40. Okay, and I know you don't have a grid, but just do the best you can. Okay, our next point is at 470. So 70 would be right between 60 and 80. Then we're going to go to 6 100. And then finally 8 and 130. So again, I apologize that these are not already drawn for you. So here, we want to figure out the rate of change and the initial value. Okay, the rate of change and the initial value. Okay, Mark, you need to go back to the seat that you belong in because Drew's not writing anything and that I don't want. Yeah, you can't sit there. Okay, that's great. Now let's get the rest done. No, Mark, move. So, first let's figure out rate of change. What is another word for rate of change when we're talking about a graph? The slope, okay? How do we find the slope? Okay, so rate of change or slope. How do you find the rate of change or slope for something? How do we find the rate of change or the slope? We figure out what? Slope is rise over run. So how do we get from one point to the next? How much do you go up if you go from 40 to 70? 40 to 70, you go up how much? How do you get from 40 to 70?
30.
You go up 30, okay, and then how far would you go over? If you go over from 2 to 4?
2.
Over 2. So if you reduce that, what is your rate of change? What's 30 divided by 2? What does that reduce to be?
15.
15. Okay, so my rate of change would be $15, basically. So $15. So what does that tell you? Is that telling you how much it costs to start or how much it costs per hour? Is that how much it costs just to do anything, or is this the per hour charge? Per hour. Okay, $15 is the hourly fee. How do you know that that's the per hour charge? Because we know that we're going in number of hours, okay? So if we go up divided by over, it's cost over hours. So that's the per hour charge. How would you figure out how much it costs to start? Any ideas? How do you find out the firing fee or the baking fee? How would you do that? Any ideas? This is basically a line, right? Could you figure out the y-intercept of the line? Because basically we want to figure out if this was a line, okay, and we tried to draw this. I want to figure out, could you figure out what the y-intercept is of that line? How could you figure out what the y-intercept is? Any ideas? We want to figure out where it starts, but how do you know exactly where it starts? Slope is rise over run, right? So can you go backwards? Okay, if we're going up and over, can I figure out, we know that these are points right here on the line. Can I figure out where one would be at 0 hours? That would be your firing fee or your baking fee. How do we figure out what this point is right here? It's going to have the same slope. Okay, to get from here to here, you'd have to go up 30 over 2. So how would you figure out to get from 40 to go down, you'd have to go what? Down 30 and also over 2. What's down 30 from 40? 10. And how many hours? If you go over from 2 to 0, 0, right? So this point tells you that you would be at $10. Okay, that's telling you your initial value. So initial value means what? Is that your hourly fee here, or are we figuring out, I'm sorry, is that your hourly fee or your starting value? Starting value. So $10 is the initial fee. Okay, so initial value is where you start. Initial means where you start. Okay, so we're figuring out those two parts. So you can figure out, you can also go backward. So a lot of times we're starting at something and we're moving up. We can always move to the left as well. Okay, let's try another one for number 2. Okay, for number 2. Let's see. Again, we want to find and interpret rate of change and initial value. Okay, so we're going to say each week Sam works the same number of hours. He has a really regular job and he always works the same number of hours. Okay, let's see. Each week Sam works the same number of hours. The equation of the line her equation is y equals 12x plus 24. The first week, she had an orientation. Right, the first week she had an orientation. The total number of hours she worked weeks 2, 3, and 4 was 20 hours, 28 hours, and 36 hours. Okay, we want to find and interpret rate of change and initial value. Find and interpret rate of change and initial value. So what they're doing here is basically they're telling you this is the line that, and we're not giving you the line here, okay? This would be the equation of the line for how much she's ever worked, okay? So for how much she's worked completely total, okay? The total number of hours she's worked in weeks 2, 3, and 4 was 20, 28, and then 36, okay? So what we want to figure out here is basically we want to make points out of these. Okay, we want to make points out of these. So in the second week, okay, so her number of weeks, and this is the number of hours. So in week 2, how many hours did she work? She had a total of 20 hours. By week 3, she had a total of 28 hours. And by week 4, she had a total of 36 hours. So we want to figure out what is the rate of change and what was the initial value. Okay, we want to figure out what is the rate of change and what is the initial value. So how would we start? How do you figure out the rate of change or the slope? How do you figure out how much is it changing to get from week to week? You're adding 1 for weeks. How many hours are you adding each week? 8. So what that tells you is, I can't even talk right now. Sorry. So what that tells you is that her rate of change is what?
8.
Rate of change is 8 hours. So what does that tell you about how many hours she works per week? So if each week she's adding 8 hours to her total, what does that tell you? She works 8 hours each week. Okay? Can we find the number of hours she worked in the first week? So the first week she would have worked what? How many hours? She would have worked 12 hours. Okay? The first week, or actually her actual first week, she had a total of 8 hours worked. Before she could work, though, she had to go to an orientation. Can we figure out how long the orientation was? How would we go back to 0 before she started working? How would you go backwards? Subtract 8. So in her orientation, it must have been what? Orientation must have been 4 hours. Hopefully it wasn't all in one. Okay? So using graphs, we can go backwards. Okay? That's what we're actually doing with all these graphs today. We're trying to go backwards. Okay? So after her first week of work, she had done 12 hours total. But before she could start, she obviously had to attend a 4-hour orientation. Okay? So this would be your initial value. This is your rate of change. Okay? Do we have questions on how I did that? Okay, let's do one more and then I think we can be good. Okay, so for number 3, okay, for this one I'm going to show you a table. Okay, so we're going to see the table shows the weight of a puppy. The table shows the weight of a puppy in weeks 4, 5, 6, and 7. Okay, so we're going to write a table showing the weight of a puppy. Okay, we're going to say assume a linear relationship. So we're saying assume that this puppy is growing at a constant rate. Okay, so it's not like it's gaining 2 pounds one week and then 3 pounds next week. It's growing consistently. Okay, so that's what we call a linear relationship. We want to find and interpret the rate of change. Find and interpret the rate of change and initial value. Okay, and we're going to draw you a chart. Okay, so we're going to say number of weeks and pounds. So when it was 4 weeks old, and I'm intentionally going to leave a space there. When it was 4 weeks old, it was 17 pounds. 5 weeks, it was 20 pounds. At 6, it was 23. And at 7 weeks, it was 26 pounds. I drew that way too long, sorry. So I'm going to leave a space on purpose. Okay, I'm going to leave a space on purpose. So I'm going to find the rate of change and the initial value. Okay, so when it was born, basically. When it was born, how many weeks old would it be? 0 weeks. Okay, so make sure we understand that we're actually starting at 0. Destin, you should be writing this down. So if I want to go backwards, what is my rate of change? How much is it gaining each week? 3. Okay, so rate of change equals 3 pounds. Okay, and pounds you can abbreviate as LBS. I really have no idea why that's the abbreviation for pounds, but I know it is. Because none of those letters are in the word pounds. I don't know. Okay, so rate of change is 3 pounds. How could we go backwards? -3. So that means in The third week, how big would it have been? 14 pounds. So I'm going to try to draw in a couple extras here. In the second week, it would have been how many pounds? 11 pounds. In the first week, it would have been how many pounds? 8 pounds. So when it was born is at 0 weeks, it would have been 5 pounds. Okay, so that's what we call the initial value. So initial value is starting value. Remember, you're always starting at 0, not at 1. Okay, so initial value was 5 pounds. Okay, so we're going to be interpreting rate of change and interpreting different functions. Okay, so homework for today, you are going to be working on you are starting on page 323. 323, you're doing numbers 1 through 6. Okay, on page 323, you're working on numbers 1 through 6. Okay, you guys, we go ahead and get started. I'm going to call a couple people up to my desk.